Hello students, welcome to this lecture 1 polynomials. So in today's lecture, we will discuss introduce polynomials. Okay, then we'll discuss geometrical meaning of the zeros of a polynomial and then relationship between zeros and coefficients of a polynomial. Okay, so let's get started. So in class 9, you have studied polynomials in one variable and their degrees. Okay. So recall that if p of x is a polynomial in x, then the highest power of x in p of x is called the degree of the polynomial p of x. Okay. So in generally, we write polynomial in the form p of x is equal to a0 plus a1 times x plus a2 times x square plus dot 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 an x to the power n. Okay, so here this is called polynomial if a0, a1, a2 dot dot a1 all are real numbers. Okay, and the power of variable is whole number. Okay, so power of the variable should be whole number. Then this expression will call polynomial. Okay, in your class 9th, you have studied there are so many types of polynomial. Okay, like linear polynomials, quadratic polynomials, cubic polynomials. Okay, so linear polynomials basically it is in the form linear polynomial ax plus b. Okay, so this expression ax plus b, this expression is called linear polynomials. Okay, so a linear polynomial basically in the form ax plus b. Okay, then we also introduce the term degree of the polynomial. Okay, so degree of the polynomial is basically actually if we have polynomial p of x. Okay, so p of x is a polynomial in x variable. The highest power of variable x in p of x, that is called the degree of the polynomial. Okay, so for this expression if an not equal to 0, okay, and a0, a1, a2 up to n all are real numbers. Okay, then this expression p of x, for this polynomial p of x, the degree of this polynomial is n, since the highest power of the variable x is here n when n not equal to 0. Okay, so now a linear polynomial with degree linear polynomial is a polynomial that has degree 1. Okay, so if you have a polynomial with degree 1, then that polynomial is called linear polynomials. Okay, and the form of linear polynomial is ax plus b. And then if the degree of the polynomial is 2, then that polynomial is called quadratic polynomials. Okay, and the general form of quadratic polynomial is what? Ax square plus bx plus c. So this is the general form of the quadratic polynomial. Okay, so for this expression here you can see the highest power of the variable x is here 2. Okay, so the degree of this polynomial is 2, and we know the degree 2 polynomial is called quadratic polynomial. Okay, and then cubic polynomial. So you have studied about also cubic polynomial. So what actually does mean by cubic polynomial? Okay, so a polynomial with degree 3 is called cubic polynomial. Okay, so if we have a polynomial with degree 3, then that polynomial is called cubic polynomial. Okay, and the general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c and d are from real numbers. Okay, and a should be not equal to 0. Okay, then this polynomial is called cubic polynomial. So student, you have already studied about them. Okay, so now there are some examples of polynomials. Okay, so here 4x plus 2, this is a polynomial in the variable x, and here the highest power of variable x is 1, so the degree of this polynomial is 1. Okay, and for second one, here 2y square minus 3y plus 4, so this is a example of a polynomial, and here this polynomial, the variable for this polynomial, the variable is y. Okay, so this is a polynomial in variable y, and degree is equal to 2. Okay, since here the highest power of the variable y is 2. Okay, so the degree of this polynomial 2y square minus 3y plus 4 is equal to 2. And third, we have this polynomial 5x cube minus 4x square plus x minus root 2. Okay, so this expression is a polynomial in variable x, and the degree of this polynomial is 3. Okay, since the highest power of the variable x is here 3. Okay, so the degree of this polynomial is 3, and this expression 7 times u to the power 6 minus 3 by 2 times u to the power 4 plus 4u square plus u minus 8. Okay, so this expression is an example of polynomial in variable u of degree 6. Okay, so now let us move to let us look to some expressions like 1 over x minus 1, root over x plus 2, 1 over x square plus 2x plus 3, etc. This type of expression are not polynomials. Okay, so this type of expression not polynomials. So a polynomial of degree 1 is called linear polynomials, and for example you can take 2x minus 3 root 3 times x plus 5 y plus root 2 times root 2 and x minus 2y 11 3z plus 4 2y 3 times u plus 1, etc. all are linear polynomials. Okay, and the polynomials such as 2x plus 5 minus x square, x cube plus 1, etc. are not linear polynomials. So this polynomial actually a quadratic polynomial. Okay, and this polynomial is a cubic polynomial. Okay, and this expression are not polynomials since here the power of the variable x is not a whole number. Okay, so that is why this expression 1 by x minus 1 root over x plus 2 1 over x square plus 2x plus 3 etc. are not polynomials. Okay, so for being polynomials, the power of the variable x should be whole number. Okay, otherwise that expression will not polynomials. Okay, so now let us move to next slide. So a polynomial of degree 2 is called a quadratic polynomial. Okay, and the name quadratic has been derived from the word quadrate, that means square. Okay, so for example you can take this expression 2x square plus 3x minus 2 over 5. Okay, so this is a quadratic polynomial since the degree of this polynomial is 2. Okay, so this is a quadratic polynomial in variable x, and here y square minus 2, this is also a quadratic polynomial in variable y. Okay, with degree 2, and here 2 minus x square plus root 3 times x, this is also an example of quadratic polynomial. Okay, so similarly u by 3 minus 2u square plus 5 is also a quadratic polynomial. Root 5 times b square minus 2 by 3 times b is also a quadratic polynomial. 4z square plus 1 by 7 is also a quadratic polynomial. So these are some examples of quadratic polynomials whose coefficients are real numbers. Okay, so these are some examples of quadratic polynomial. Now more generally, any quadratic polynomial in x variable is of the form ax square plus bx plus c. Okay, so this is the general form of a quadratic polynomial. Okay, so the most general form of the quadratic polynomial is ax square plus bx plus c, where a, b and c are real numbers and a should be not equal to 0. Okay, now a polynomial of degree 3 is called a cubic polynomial. Okay, so if we have a polynomial with degree 3, then that polynomial is called a cubic polynomial. Okay, so some examples of cubic polynomial are 2 minus x cube, root 2 times x cube, 3 minus x cube, 3 minus x square plus x cube, and 3x cube minus 2x square plus x minus 1. These are some examples of a quadratic. These are some examples of a cubic polynomial. Okay, so in fact, the most general form of a cubic polynomial is ax cube plus bx square plus cx plus d. Okay, so the most general form of a quadratic polynomial is ax cube plus bx square plus cx plus d. Okay, so now where a, b, c, d are real numbers and a not equal to 0. So now consider the polynomial p of x. P of x, this is equal to x square minus 3x minus 4. Okay, so this polynomial is basically a quadratic polynomial since the degree of this polynomial is 2. Okay, so here we consider the polynomial p of x, that is equal to x square minus 3x minus 4. Okay, then putting x is equal to 2 in the polynomial. Okay, then we get p of 2. This is basically equal to 2 square minus 3 times 2 minus 4. Okay, and if we calculate it, then we'll get this is equal to minus 6. Okay, so the value minus 6 we obtain by replacing the value x by 2. Okay, so in x square minus 3x minus 4. Okay, so in x square minus 3x minus 4, here we replacing x is equal to 2 and we get the value of p of 2. This is equal to minus 2. Okay, so the value of x square minus 3x minus 4 at x is equal to 2, that can be also written as p of 2. Okay, similarly p of 0. So here basically by replacing the value x by 0, we get the value of p of 0. Okay, so p of 0 is the value of p of x at x is equal to 0, and if we replacing the value of x is equal to 0 in the polynomial x square minus 3x minus 4, then the value is minus 4. Okay, and if p of x is a polynomial in x and k is any real numbers, okay, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k. Okay, and it is denoted by p of k. Okay, so p of k, that means actually the value of p of x at x is equal to k. Okay, so now what is the value of p of x is equal to x square minus 3x minus 4 at x is equal to minus 1. So here replacing the value of x is equal to minus 1 in polynomial p of x is equal to x square minus 3x minus 4. Okay, then we have p of minus 1. This is equal to minus 1 whole square minus 3 times minus 1 minus 4. Okay, and if we calculate this, then we'll get this is equal to 0. So at x is equal to minus 1, the value of p of x is equal to 0. Okay, also note that if we replacing the value of x is equal to 4, then we get the value of p of 4. Okay, so p of 4, this is equal to 4 square minus 3 times 4 minus 4. Okay, and this is equal to 0. Okay, so as p of minus 1 is equal to 0 and p of 4 is equal to 0, so minus 1 and 4 are called the zeros of the quadratic polynomial x square minus 3x minus 4. Okay, so here more generally, a real number k is said to be a 0 of a polynomial p of x if p of x is equal to 0. Okay, so if p of x is equal to 0, then p of k is equal to 0, then x is equal to k. This is called 0 of that polynomial. Okay, so here you see at x equal to minus 1 and x equal to 4, the value of p of x is equal to 0. So minus 1 and 4 are the zeros of the quadratic polynomial x square minus 3x minus 4. Okay, now you have already studied in class 9 how to find the zeros of a polynomial. Okay, there actually we factorize the polynomial. Okay, then we equate that equal to 0, and by solving that equation we get the zeros of a polynomial. Okay, so here we can find the zeros of a linear polynomial. So for example, if k is a 0 of the polynomial p of x is equal to 2x plus 3, okay, then p of k should be 0. So it gives us 2k plus 3, this is equal to 0, and if we solve this equation, then that is k is equal to minus 3 by 2. Okay, so in general, if k is a 0 of p of x is equal to x plus b, then p of k, this is equal to ak plus b is equal to 0, that is k is equal to minus b upon a. Okay, so if we replace x equal to minus b upon a at the polynomial p of x is equal to x plus b, then we get p of minus b upon a, this is equal to 0. Okay, so the 0 of the linear polynomial ax plus b is equal to minus b upon a. Okay, and that is basically equal to minus coefficient of x minus constant term divided by coefficient of x. Okay, so the 0 of a linear polynomial, that is actually minus b upon a, and that is actually equal to minus constant term divided by coefficient of x. Okay, now thus the 0 of a linear polynomial is related to its coefficients. Okay, so 0 of a linear polynomial, that is actually minus b upon a, and if we have a linear polynomial p of x equal to ax plus b, then the 0 of a linear polynomial minus b upon a, that is actually equal to minus constant term divided by coefficient of x. Okay, so 0 of a linear polynomial is related to its coefficients. Okay, so does this happen in the case of other polynomials too? Okay, so for example, are the zeros of a quadratic polynomial also related to its coefficients? Okay, so in this chapter basically we'll try to answer these questions. Okay, so we'll also study the division algorithm for polynomials. So you know that a real number k is a 0 of a polynomial p of x if p of k is equal to 0. Okay, so you know already that a real number k is a 0 of the polynomial p of x if p of k is equal to 0. And but why are the zeros of the polynomial so important? To answer this, first we'll see the geometrical representation of linear and quadratic polynomials and the geometrical meaning of their zeros. Okay, so consider first a linear polynomial ax plus b where a not equal to 0. Okay, so you have studied in your class 9 that the graph of y is equal to x plus b, that is actually a straight line. Okay, so for example, the graph of y is equal to 2x plus 3 is a straight line passing through the point minus 2 comma minus 1 and 2 comma 7. Okay, so here the table, the values of x and here the values of y. So when x is equal to minus 2, then the corresponding value of y, that is equal to minus 1. Okay, and when x is equal to 2, then the corresponding value of y is equal to 7. Okay, so here we get 2 points minus 2 comma minus 1 and 2 comma 7. Okay, so now we can plot on the graph. Okay, we can plot on the graph these 2 points. So then if we plot this point on the graph, then we can join these 2 points and we'll get a straight line. Okay. So from the figure, you can see that the graph of y is equal to 2x plus 3 that intersects the x-axis midway between x is equal to -1 and x is equal to -2. Okay, that is at the point -3 by 2 comma 0, it intersect at x-axis. Okay, so you also know that the 0 of 2x plus 3, this is actually -3 by 2. Okay, so that's the 0 of the polynomials 2x plus 3 is the x coordinate of the point where the graph y is equal to 2x plus 3 intersects the x-axis. Okay, more generally, the 0 of the polynomial is the x coordinate of the point where the graph of that polynomial intersects the x-axis. Okay, so here you can see the graph. So this is the graph of the function y is equal to 2x plus 3. So y is equal to 2x plus 3. This graph intersects at -3 comma 2 comma -3 by 2 comma 0. Okay, and the x coordinate of this coordinates is -3 by 2. Okay, so and we also know the 0 of 2x plus 3 is -3 by 2. Okay, so from this graphical representation, we can conclude that the 0 of the polynomial 2x plus 3 is the x coordinate of the point where the graph y is equal to 2x plus 3 intersects the x-axis. Okay, now in general, for a linear polynomial ax plus b where a not equal to 0, the graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly one point. Okay, and that point namely -b upon a comma 0. Okay, so the graph of the linear polynomials exactly intersect the x-axis at exactly one point, and that point basically -b upon a. So therefore the linear polynomials ax plus b where a not equal to 0 has exactly 1 0. Okay, and namely the x coordinate of the point where the graph y is equal to x plus b intersect the x-axis, and that point basically the 0 of the linear polynomial. Okay, now let us look for the geometrical meaning of a 0 of a quadratic polynomial. Okay, so here we consider the quadratic polynomial x squared minus 3x minus 4. Okay, so let us see what the graph of y is equal to x squared minus 3x minus 4 looks like. So let us list a few values of y is equal to x squared minus 3x minus 4 corresponding to a few values for x as given in table. Okay, so in table we have given some values of x and we get the corresponding values of y. Okay, so when we take x is equal to -2, then we get the value of y is equal to 6. Okay, and when x is equal to -1, then we'll get the corresponding value of y, this is equal to 0. Okay, and when x is equal to 0, then we'll get the corresponding value of y is equal to -4, and when x is equal to 1, we'll get the value of y is equal to -6, and when x is equal to 2, then we'll get the value of y is -6, and when x is equal to 3, then we'll get the value of y is equal to -4, and when x is equal to 4, then we'll get the value of y is equal to 0. Okay, and when x is equal to 5, then we'll get the value of y is equal to 6. Okay, so if we locate the points listed above on a graph paper and draw the graph, so it will actually look like the one given in figure. Okay, so if we plot all these points on a graph paper and draw the graph, then it will actually look like the graph this. Okay, this. So in fact, for any quadratic polynomial ax square plus bx plus c, where a not equal to 0, the graph of the corresponding equation y, this is equal to ax square plus bx plus c, has one of the two shapes, either open upwards like, okay, or open downwards like. So it totally depends on the sign of a. Okay, so depending on whether a greater than 0 or a less than 0. Okay, and these curves are called parabolas. Okay, so you can see from table that -1 and 4 are zeros of the quadratic polynomial. Also note that from figure that -1 and 4 are the x coordinates of the points where the graph y is equal to x square minus 3x minus 4 intersects the x-axis. Okay, thus the zeros of the quadratic polynomial x square minus 3x minus 4 are x coordinates of the points where the graph y is equal to x square minus 3x minus 4 intersects the x-axis. Okay, this fact is true for any quadratic polynomial. That is, the zeros of a quadratic polynomial ax square plus bx plus c, where a not equal to 0, are precisely the x coordinate of the points where the parabola representing y is equal to x square plus bx plus c intersects the x-axis. Okay, so zeros of a quadratic polynomial are precisely the x coordinates of the point where the parabola y is equal to x square plus bx plus c intersects the x-axis. So from our observation earlier about the shape of the graph y is equal to x square plus bx plus c, the following three cases can happen. Okay, so there are three cases that can be happen for about the graph shape of the graph. Okay, y is equal to x square plus bx plus c. So first case 1, here the graph cuts x-axis at two distinct points a and a dash. Okay, and the x coordinates of a and a dash are the basically two zeros of the quadratic polynomial. Okay, quadratic polynomial x square plus bx plus c in this case. So in this case, here you can observe here by this graph. Here the graph of the polynomial y equal to x square plus bx plus c is often downwards. Okay, so we know when the coefficient of x square is negative, that case we get the graph of the y is equal to x square plus bx plus c is often downwards. Okay, and here you can see this graph intersects at 2 points a and a dash. Okay, and the zeros of these quadratic polynomials are basically the x coordinates of a and a dash. Okay, and in second graph, here you can see this graph is look like open upwards. Okay, so here basically the coefficient of x square is positive. Okay, and here you can also observe that this graph intersects x-axis at 2 points a dash and a. Okay, and the zeros of this quadratic polynomial are actually the x coordinates of a dash and a. Okay, and in case 2, here the graph cuts the x-axis at exactly 1 point. Okay, that is at two coincident points. So the 2 points a and a dash of case 1 here coincide here to become 1 point a. Okay, they coincide and they become 1 point a. So the x coordinate of a is the only zero of the quadratic polynomial ax square plus bx plus c in this case. Okay, and now case 3. In case 3, here the graph is either completely above the x-axis or completely below the x-axis. Okay, so it does not cut the x-axis at any point. So the quadratic polynomial ax square plus bx plus c has no 0 in this case. Okay, so the quadratic polynomial ax square plus bx plus c has no 0 in this case. So I stop here this lecture. Thank you very much to all of you.